Determining RS configuration of chiral compounds does not have to be difficult. You don't have to rotate the molecule or do any awkward hand gestures. Let me show you. So let's say I have a molecule that looks something like this, a cyclohexane ring with a wedged out hydroxide group and a ketone up here. So how do I determine RS configuration? Well, first step is to identify your chiral carbon. And the chiral carbon is the carbon that has 4 single bonds to 4 different things. I know you don't see 4 single bonds here, but just know wherever there's a wedge, there is a dash. So I'm going to dash out the hydrogen, which is hardly ever shown in organic compounds. So our next step would be to determine the priority of each of the substituents on the 4 single bonds. How am I going to do that? Well, I start at the chiral carbon and I go 1 atom away in each direction. So when I go this way, I have an oxygen. When I go this way, I have a carbon. When I go this way, I have a hydrogen. And when I go this way, I have another carbon. Well, oxygen is what I call the fanciest of all the atoms because it has the highest atomic number of all atoms that we looked at here. So this will get priority 1. So now I know that hydrogen is the lowest atomic number, so I know it's going to get priority 4. So I'll decide between these 2 carbons or these 2 substituents as to which one will get priority 2 and priority 3. How would I do that? Well, I go to the next attached atom in each direction. So when I go down this way, I have another carbon. When I go up this way, I have an oxygen. And once again, oxygen, because of its higher atomic number, it's the fancier atom. So this will get priority 2. Therefore, this will be priority 3. And once again, hydrogen is priority 4. Now, do notice that the lowest priority, priority 4, is on a dash, meaning pointing into the page, which means this is in proper orientation for us to determine RS configuration as is, which means all I have to do now is rotate from 1 to 2 to 3. And I see that it's counterclockwise rotation, left rotation, which is S. So this chiral compound is an S configuration molecule. So let's determine RS configuration with this molecule. So just like before, the first thing I'm going to do is identify the chiral carbon, which is right here. And notice a chiral carbon is one with 4 single bonds to 4 different things. And I know you don't see 4 bonds, you only see 3. But remember, wherever there's a dash, there is a wedge. So I'm going to go ahead and wedge out the hydrogen, which is hardly ever shown. So now I'm going to determine the priority 1, 2, 3, or 4 on each of these 4 substituents. And I'm going to do it the same way I did it before. I'm going to start at the chiral carbon and go 1 atom away in each direction. So when I go this way, I have a carbon. When I go this way, I have a carbon. And when I go this way, I also have a carbon. When I go this way, I have a hydrogen. And I already know that hydrogen is the lowest atomic number. So this is probably going to get priority 4. So I'm going to decide on priority between these 3 substituents. So I'm going to go to the next attached atom in each direction and see which one has the highest priority and lowest priority. So when I go this way, I have a carbon. When I go this way, I have a bromine. When I go this way, I have an oxygen, or this oxygen is fair game as well. But I already know that bromine has the highest atomic number here, so it's the fanciest atom. So this will get priority 1. Oxygen is the next fanciest atom for its highest atomic number between it, oxygen, and carbon. So this will be priority 2, and therefore this will be priority 3. And like I said, hydrogen is priority 4. So now, notice the hydrogen is on a wedge, which means coming out of the page, which is not proper orientation to determine RS configuration as is, but we're going to do it the same way we did it before. We're going to rotate from 1 to 2 to 3. Which is left rotation or counterclockwise rotation, which is S. However, if your 4th priority is not in proper orientation, meaning not on a dash, not pointing into the page, we're going to flip our answer to R. That's it. That's how you determine RS configuration with a molecule that's not in proper orientation. You do not have to flip the molecule around, rotate it, or use any awkward hand gestures to determine RS configuration. Simply just change your answer to the opposite. This is an R chiral compound. So how about this fancy little molecule? So even though it looks more complex, we're going to do it just the same way as we did it in the previous two examples. First thing we're going to do is identify our chiral carbon, which is right here in the center. And we're going to determine the priority of each of the 4 bonds that we have, 4 single bonds, 4 different substituents. So I'll do it the same way as I did before. We'll go 1 atom away in each direction. So when I go this way, I have a carbon. When I go this way, I have a carbon. When I go this way, I have a carbon. And when I go this way, I have a nitrogen, which is indeed fancier than the carbons. So this will get priority 1. So then when I come down here, I go to the next attached atom. So when I go this way, there is no next attached atom, so this is probably going to be priority 4. So I'll decide between these two as to what's priority 2 and priority 3. So I'll go to the next attached atom in each direction. So I'll go this way, and I have a carbon, and then I'll go this way, I have another carbon. Well, now what do I do? Then I go to the next attached atom in each direction. So when I go this way, I have another carbon. When I go this way, I have another carbon. However, this carbon has an oxygen attached to it, while this is just boring old hydrocarbon ring. So this will get priority 2, and this will get priority 3. Now notice our 4th priority is indeed in proper orientation to determine R's configuration as is, meaning it's on a dash pointing into the page. So all I have to do now is rotate from 1 to 2 to 3, which is right rotation, or clockwise, which is R. That's it. This molecule is an R configuration compound. Simple as that. So here's an example of an infamously difficult chiral compound to determine R's configuration, let alone identify the chiral carbons. So this example looks like it may have multiple chiral carbons. For instance, this may look like a chiral carbon. However, be careful. These are both methyl groups, meaning this carbon has 2 of the same substituents attached, which means it is not a chiral carbon. This is not a chiral carbon because it has only 3 bonding regions, 1 double bond and 2 single bonds. But we do have a chiral carbon here as well as here. The intersections of the rings are the ones that are usually missed when determining how many chiral carbons we have. Well, we're going to focus on 1 chiral carbon to determine R's configuration. So we'll start with this chiral carbon. So I have 4 single bonds to 4 different substituents. Basically, it looks different when you go in each direction. So they are indeed 4 different substituents. So how do I determine R's configuration? How do I determine priority groups? Well, we're going to do the same thing we've done in any other videos that I've done about R's configuration. We're going to start at the chiral carbon, and we're going to go 1 atom away in each direction. So when I go this way, I have a carbon. When I go this way, I have a carbon. When I go this way, I have a carbon. And when I go this way, I have a carbon. Well, I notice that this carbon doesn't have anything else attached to it, so it's most likely going to be our 4th priority. So then we'll have to decide among these 3 as to which is priority 1, 2, and 3. So once again, I'll go to the next attached atom in each direction. So when I go to this carbon, I go to the next attached, which is also a carbon. When I go this way, I go to the next attached, which is also a carbon. And when I go this way, I go to the next attached, which is also a carbon. Or I could go in this direction, which is also a carbon. But I do notice that this carbon, or this direction, has an oxygen attached to it, which is fancier than any of the other carbons or structures. So this will get priority 1. And I notice that this carbon is a quaternary carbon, meaning it is attached to 4 other carbons, which is more than either of these 2 carbons, which are secondary, only attached to 2 other carbons each. So this will get priority 2. Therefore, this down here will get priority 3, and that's it. Do notice that our 4th priority is dashed, meaning pointing into the page, which means it is indeed in proper orientation to determine R's configuration as is. So now all I have to do is rotate from 1 to 2 to 3, which is counterclockwise or left rotation, which makes this carbon right here S configuration chiral carbon. Simple as that.